Hi guys, this is your channel Stat and Math Tutorials in a new video. In today's video I'm going to show you how to use the method of separation of variables to solve first order ordinary differential equation. And this method is applicable to differential equations of the form dy over dt equals g of y times h of t. So g of y is some expression with y, and h of t is some expression involving t. This method has 4 steps. So the first step, move all y's to the side of dy and all t's to the other side including dt. Step number 2, integrate both sides with integration constant. Step number 3 is solve for y. And step number 4 is use the initial conditions to find the constant. So let's apply these 4 steps to the following concrete example. So we have dy over dt equals square root of t times e to 2y with the initial condition y of 1 equals 2. So let's move every y's to one side and every t's to the other side, including dt. So I'm gonna divide both sides by e to the power 2y and multiplying both sides by dt. So first dividing both sides by e to 2y, then multiplying both sides by dt. So this is step number 1. So dividing by e to the power 2y is the same thing as multiplying by e to negative 2y. So it's going to be in this side, it's going to be e to negative 2y dy equals square root of t is t to 1/2 times dt. So this step number 1, I move all y's to one side and all t's to other side, including dt. Now step number 2, I'm gonna integrate both sides. So the integral e to negative 2y dy equals the integral t to 1/2 dt. So now let's find out what's the integral on the left hand side using the chain rule. So this will be negative 1/2 e to negative 2y plus some constant, so let's name it c1, equals, on the right hand side I'm going to use the power rule, so it's going to be 2/3 t to 3/2 plus some constant, so let's name it c2. And now let's solve for y. That's step number 3. So step number 3, solving for y. So this, I'm gonna just move the constant c1 to the other side. So negative 1/2 e to negative 2y equals 2/3 t to 3/2 plus c2 minus c1. And I'm just gonna substitute capital C for c2 minus c1. So I end up with negative 1/2 e to negative 2y equals 2/3 t 3/2 plus c. Then I'm gonna multiply both sides by negative 2. So I get e to negative 2y equals, so equals 4/3 or negative 4/3 t 3/2 minus 2 capital C. That's capital C. Now I'm gonna solve for 2y's by applying natural log to both sides. So negative 2y's equals natural log, so the absolute value negative 4/3 t 3/2 minus 2c. And now dividing both sides by negative 2 to get y by itself. So I'm gonna divide both sides by negative 2, so I get y equals negative 1/2 natural log absolute value of negative 4/3 3/2 minus 2c. So now I'm going to use the initial condition to find out what's the constant c. So y of 1, we are told y of 1 is 2. So y of 1 is 2. So apply here. So y of 1 is 2, so it's going to be 2 equals negative 1/2 natural log minus 4/3 minus 4/3 minus 2c. And now multiplying by negative 2 again, so I get negative 4 in this side and natural log negative 4/3 minus 2c. And now to solve for c, I'm going to exponent both sides. So e to negative 4 equals negative 4/3 minus 2c. So again, 2 is constant, c is constant. I'm just gonna substitute I don't know, c prime for 2c, so c prime. So now if I add 4/3 to both sides, so plus c prime here, doesn't matter, plus or minus is just a constant. So adding 4/3 to both sides, so I get e to negative 4 plus 4/3, that's give me c prime. Now the final answer or the general solution for this differential equation, it's y of t equals negative 1/2 natural log of negative 4/3 t 3 halves, and plus that's constant, which is e to negative 4 plus 4/3. So this is my final answer to the differential equation we start with, including the initial condition y(1) equals 2. So I hope you enjoy watching this video. I will pause here and continue next time. Thanks for watching.